I'm welcoming you all once again to this channel. Today I'm going to make a video on someone's request. So I have received one request to create a cell with 2 root 3 cross 3. So how to create this kind of cell, that we will see in today's video. So similar kind of video I have also made earlier. So based on that we will try to learn this. So here I have made some slides on this hexagonal primitive 2D basis. So here here I have noted down some key facts for hexagonal primitive 2D basis. So as we know that a very standard primitive cell with which is in a plane has a basis of a vector, that is a1 which is a0 and a2 which is minus a by 2 and root 3 by 2a. So this is a very standard hexagonal primitive cell vectors. And if we will find the squared length of the vector, then we can write it as v is equal to p a1 plus q a2, and the modulus for this will be a square p square minus pq plus q square. So if you will put this a1 and a2 value in this here in the v, then you can have the dot product of both, then you will find this value. And next, if we will try to write the signed area scale, like if we will write this in a 2 by 2 integer submatrix, we can write it simply as p1 p2 q1 q2, and this is nothing but a matrix. As I'm doing in the slide, I was not having a long bracket to give over here, that's why I have written it like this. And this value can also be this matrix can also be represented as p1 q2 minus p2 q1. The absolute value delta mod is the in plane area multiplier. And so it will also tell us that how many primitive unit cell lattice are present here. So why we are doing all this, we can see the next slide and it will be clear to all of us. Next is how to find this 2 root 3 cross 3 kind of matrix. So here what we want is, we want our a vector to be 2 root 3 a and b to be 3a. So for if we are going towards with this b, then for b it's very easy to choose any integer, like the integer will be a pb and qb, such that this p square, like the formula that we have derived here, this vector formula, that there we can put this value and we will get like p square minus pb qb plus qb square is equal to 3 square, and because it is this value is 3 and which is equal to 9. So to choose the simplest solution, we can have PB and QB as 3 0, where B is equal to, where V is nothing but 3A1. Okay. So this is the very simple solution we can find for this one. And similarly for A, if we can try to do the same thing, then similar way we have put that value in this equation, and here we will get this 2 root 3 square is equal to 12. And now to find the smallest integer pair which will satisfy this above equation, we have here 4 and 2 value. And after putting these values over here, it satisfied this value as equal to 12. And now so this is our lattice vector. Now we have our 4a1 plus 2a2 for the a and 3a1 for the b. Now to check this determinant, we are going PAQB minus PBQA, exactly similar here as we have written P1Q2 and P2Q1. So similar thing we have only did with A and B vector, and here we found that this value is minus 6 and the absolute value for this will remain as 6. Next is, based on these numbers we have tried to write the integer matrix. So here you see that in the plane part of m becomes, so m is our integer matrix, so the in plane part of this matrix will become 4 3 and 2 0, so which came from here. So 4 and this 3, then 2, and here this a2 part is 0 for b vector. That means we can simply write it as 3a1 plus 0a2. So similar way we have written this submatrix as this much. And now after now we can pick the column pairs and pairs q1 qa q p p PA, QA and PB, QB and assemble them in the integer matrix M. So here we can write like our integer matrix will become PAPB0, QAQB0, 0, 0, 1. So this way we have kept these values of PAPB and QAQB here. So you see that our integer matrix now become 4, 3, 0, 2, 0, 0, 0, 0, 1. So using this matrix now we can transform our lattice so that we will get this kind of vector like 3 root 3 cross 3. Okay, so let me go and open my postcard file in Vesta. So here I am opening the same postcard which I have done the like we I have chosen to do the earlier video also. So this one is the postcard. Now what we will do, we will simply go to edit, then unit cell, then in the transform we will provide that matrix which we have derived now, that was 4 3 4 3, and here it was 2 I think, and this is 0 and this is 0, 0, 1. Okay, let's go here and yes, yes, this one. Okay, apply. Okay, so now you can see. Okay, let me also open the same Vista file again so that we can see the difference. So here the initial postcard was like this and we were having 90 90 120 degree, and after doing this matrix thing we found this as a vector where this angle is 90 90 30. Now you can compare also this A and B vector, you will get 2 root 3 and 3, which is okay. But now I also have one doubt that whether this is not a kind of a rectangular lattice nor even a hexagonal, because this is not 60 degree or neither 30 120, rather it's 30 degree. So whether this kind of lattice is existing or not, it is possible or not, that you need to verify. As per your request, just I have tried to come out with this solution, but I don't know whether you can use it for further calculation or not. And also there are certain rules to do this kind of thing and to transform this matrix with different root 3 kind of values. So earlier what I did, I think I did with 3 yes, I did with 3 cross 2 root 3, but this is exactly opposite of that, I think 2 root 3 cross 3. So we don't know, like I also don't know whether this kind of lattice will be possible or not. So kindly check it before going ahead. And but this way, whenever you have any other values, this way you can follow like this kind of way of lattice, a primitive 2D base. From primitive 2D basis you can come with your integer matrix. Okay, so this much for today's video only, and thank you all and bye bye.